Hi, welcome back. In this video, we will be discussing one of the most essential and ubiquitous data structures in computer science and software engineering. Tree data structure. Tree data structure is hierarchical in nature that imitates the organization tree of a real-world system. It consists of nodes that are connected by edges. Each node can have 0 or more child nodes, and each edge connects a node to its children. The topmost node in a tree is called the root of the tree. The nodes present at the same level are called siblings, and nodes that have children are called parent nodes. Now let us consider an example where we want to store data for a franchising company that has multiple branches from which they sell their product. The hierarchy will have the following structure. The root node will represent the parent company. The next level of nodes will contain information about each regional manager under the parent company. The third level of nodes will contain information about each branch under the corresponding regional manager. Finally, the fourth level of nodes will contain information about each store under the corresponding branch of the franchising company. This hierarchy organization is the perfect example of a tree structure. Tree structures are essential in computer science because of their excellent performance in searching and sorting operations. They have important algorithms like traversal, searching, and insertion that make them fundamental in programming. One of the unique features of a tree is that it is recursive in nature. This means that it is possible to create a new tree structure for each child node of a tree. Trees are also versatile and can be used to represent many data types such as file systems, data directories, web page hierarchies, and many more. There are various operations that can be performed on a tree structure. Let us discuss some of the fundamental ones. First is traversal. Tree traversal is the process of visiting all the nodes of a tree and processing them in some way. There are mainly three types of tree traversal: in-order traversal, pre-order traversal, post-order traversal. In-order traversal, this traversal visits the left child, processes the root node, then visits the right child. Pre-order traversal, this traversal processes the root node, visits the left child, then the right child. Post-order traversal, this traversal visits the left child, then the right child, then processes the root node. The second operation is searching. Tree searching refers to the process of finding a specific node in a tree data structure. One of the most common searches is the binary search tree. In a BST, the search method compares the target value with the current node value. If the target value is greater than the current node, the right subtree is searched. Otherwise, the left subtree is searched. Third operation is insertion. Tree insertion refers to the process of adding a new node to the existing tree data structure. The process of insertion depends on the type of tree one is working with. If we consider the same BST, then we can insert a new node by comparing its value with the root node. If the value is less than or equal to the root node value, we insert it into the left subtree. Otherwise, we insert it into the right subtree to wrap up. Tree structures are one of the most fundamental and useful data structures in computer science due to their versatility, performance, and recursive nature. They are suitable for representing many real-world systems and implementing fundamental algorithms. Traversals, searching, and insertion are some of the most critical operations that can be performed on tree structures. With their usefulness and ubiquity, it is no wonder that they are still relevant and implemented in various programming languages used today.